Shared data architecture, on the other hand, is an architecture which provides the structure for the system that needs to share large amount of data between its components. The shared data structure have multiple accesses and a shared data store for retrieving persistent data. The picture here shows how the shared data structure looks like. They have multiple accesses and a shared data repository. An accessor at the same time can be a producer and an accessor, where the accessor does some computations and updates the data in the repository. The shared data storage between the data storage here is used to share the data between the components through the shared storage. One important thing about the shared data architecture is that the way the consumers discovers the data of interest is available defines what kind of shared data architecture is that. There are two types of shared data architectures. One is the Blackboard architecture and the second is the simple repository architecture. If the data consumers discovers the data of interest is available by themselves, or if the data stored they have the responsibility of retrieving the data of interest, the architecture is called the repository architecture. But if the data or if the shared data stored informs the consumers of the data of interest, the architecture is called the Blackboard architecture. In the architecture, the shared data storage has some responsibilities to take care of. The shared data storage has to maintain the shared access of the shared storage and the data persistence and avoiding deadlock, as they have to be concurrent access to the shared data repository. The access control of the shared data has to be maintained by the shared data storage. These were some of the responsibilities of the shared data storage in the architecture. When we apply the architecture, it helps us to separate data producers from the data consumers, hence leading to flexible modifiability, which we will talk about later. The architecture is usually analyzed based on the performance of the system and the security and privacy of the data and the reliability of the system, where you have to avoid deadlocks, and of course the compatibility of the data in the shared data storage, where the data is compatible with the different accessors that are accessing the shared data storage. A few of the strengths of the system here is the system is space and time efficient, where you have only one shared data storage which you have to update all the accesses of the data, and it is time efficient and you only need to have one shared data storage. Another important thing about the shared data architecture is that the design is easier to understand, as the computation is in different modules from the data storage, so makes the system more organized. Another important thing is that extending the storage is very easy, where you have to extend single shared data storage, but modifying the shared data storage is pretty hard. We also have to talk about the modifiability of the system, as you know that the computation is different from the storage. You can easily modify the accesses as long as the interface is same. They are taking an input which is available in the shared data storage. Plus, you can easily modify the data in the shared data storage, which can be easily updated to the accesses. Some of the weaknesses of the system are the changes in data storage formats affects all modules, as we talked about before. And if you change the data storage format, you have to update all the accesses or update the processing of all the accesses. The access to the shared data storage needs to be handled very properly, otherwise it will affect the stability of the system. One more thing is that the system does not support reuse due to the dependency of the accesses on the shared data. These were some of the weaknesses of the system. Let us move on to the examples. We'll talk about two examples, one for the repository architecture and the second one for the Blackboard architecture. The first example we're talking about is a symbol table in the model compilers, which is a kind of a repository architecture. A symbol table in the compilers would include the entry for each symbol defined in the table along with its attributes. So during the compilation, as the compiler encounters new definitions of the symbol, it adds them to the symbol table by just sending the add symbol message along with the appropriate arguments to the symbol table, and the definition of the symbol is added to the symbol table. And during compilation, if it encounters a reference to the symbol, sends the get attribute message to the symbol, and the reference to the symbol is returned to the compiler. This is how a simple compiler works using the symbol table. And so in the architecture or the system here, the symbol table is the shared data repository, and the compiler constantly accesses and modifies the data in the shared data storage. The second example we are going to talk about is the speech recognition system, which is a kind of a blackboard architecture. This is a simple speech recognition system where you have a recognition server, a recognition plus audio application which the user uses, an audio server, and the audio device. The speech recognition system is written in a way that it has an audio server. The audio server allows recognition to be performed without prohibiting other devices to use the audio streams available. So at the same time, the audio server can be used by multiple accessors. The recognition source or the recognition server acts as a client to the audio server, and the recognition server does not open the audio device itself. This is audio device here, and it does not open the audio device itself, rather it relies on the audio server to provide the copies of the audio streams to the recognition server. And the important thing is that this is a typical example of a blackboard architecture where the recognition server does not trigger the audio device itself, rather when a new stream of data is available, the audio server triggers the recognition server and sends and delivers the copies of the audio stream to the recognition server. This is all for the shared data storage or shared data architecture. Thank you.